Next, we will introduce a right-sided finite limit. As a part of introduction, we will discuss the definition, interpretation, and a few examples. We associate the following behavior around the point a, L with the following limit statement called the right-sided finite limit. Note that we do not suggest that the graph must approach the point as a horizontal line. It can approach from above or below or at a different angle or in any way in between. Also, the point itself may or may not be a part of the graph, and it is irrelevant what the graph looks like to the left of the point. All of these behaviors are described with the same limit statement and schematically can be expressed with an arrow starting to the right of the point and ending at the point. We say f approaches to L as x approaches to A from the right. So, to interpret the right-sided finite limit, we would first read it as f approaches to L as x approaches to A from the right. Then, we'll locate the point a, L on the coordinate plane and draw the following behavior. Note that from the statement alone, we don't know whether the graph approaches L from below or above, or whether the point itself is a part of the graph or not. Also, we don't know anything about the behavior to the left of the point. The right-sided finite limit only tells us what happens to the graph as the input approaches the target value from the right. For instance, this is what one would imagine when seeing the following limit statement. It shows that f approaches to 1 as x approaches to 1 from the right. And that's all we can learn from the limit statement alone. Let's do an example. Consider a function defined by the following graph. And let's find the following limits. In other words, let's write the right-sided limit statements to describe the behavior of the graph at the following locations. To find the limit, we need to determine the value which the function approaches to as x approaches to -4 from the right. It is easy to see that the function approaches to -1. In other words, f approaches to -1 as x approaches to -4 from the right. Therefore, the answer is -1. So we found the limit. To find the next limit, we need to determine the value which the function approaches to as x approaches to -2 from the right. It is easy to see that the function approaches 4. In other words, f approaches to 4 as x approaches to -2 from the right. Therefore, the answer is 4. So we found the limit. To find the next limit, we need to determine the value which the function approaches to as x approaches to 0 from the right. It is easy to see that the function approaches 0. In other words, f approaches to 0 as x approaches to 0 from the right. Therefore, the answer is 0. So we found the limit. Finally, to find the last limit, we need to determine the value which the function approaches to as x approaches to 2 from the right. It is easy to see that the function approaches to 4. In other words, f approaches to 4 as x approaches to 2 from the right. Therefore, the answer is 4. So we found the limit. We discussed the definition of a right-sided finite limit using the graphing approach.